Alrighty, here we go.
I mean, you can.
Since we're graduating,
Yeah.
maybe an A.
Maybe, exactly. All right, so
Potentially.
what we are going to do today and Monday, okay, we'll be looking at something called verifying trig identities. All right, and so we're going to be kind of simplifying trigonometric stuff. All right, using like sine, cosine, tangent, and then cosecant, secant, and cotangent as well. All right, this will then lead to a partners quiz on.
What is a partner? Do we take it with a
quiz
partner? Is it like
on Tuesday. It should be.
What is a partner quiz?
When? What?
What
What's
is
a
it?
partner?
Oh, you take the quiz with somebody or somebody else. Okay.
No,
So I think in the past I've allowed 2 to 3 people to work together. So I will allow that. Okay. You may, of course, fly solo.
I was willing to fight. I was willing to fight for you. Come at me, Jenna.
You lowered me.
I don't care. Just goes with my age.
Okay.
Oh, now we gotta take notes.
So, without further ado, let's take a look here. Okay. At some identities that we know, right? So identities, what makes an identity? An identity, it's when two things are exactly equal to one another, right? The same, they're identical, right? The same idea here. So we know some trig identities already, okay? So for example, secant of x is equal to what other trig function?
Cosine. Wait, no,
Nope.
the inverse of cosine.
Nope, not the inverse. 1 over the cosine of x, yes.
Reciprocal of the
Yes,
cosine.
and I mean what you say, but I do want to be careful. We practice, what we say. And so then cosecant is 1 over the sine, right? And then cotangent of x is 1 over the tangent. And then of course you could do the same thing for cosine, sine, and tangent as well. You could say that cosine of x is then 1 over what?
Cosine of x is 1 over the secant.
Yeah, 1 over secant, right, in the same kind of sense, right? And so then sine of x, in the same kind of sense, will be 1 over the cosecant of x. Okay? And then this tangent of x is equal to 1 over the cotangent of x, right? Those you might call collectively the reciprocal identities, right? Because they're all just reciprocal relationships, okay? So we may collectively refer to those as like reciprocal identities, okay? There's a few more that we know too. For example, yes, we know tangent to be 1 over cotangent, but we can also think of tangent as what over what? Sine over cosine. Sine of x over the cosine of x. Okay? That's true. And then we should also then be able to identify cotangent of x as being what over what? In a similar sense. Cosine of x over the sine of x. Okay, so. And then there's 3 more identities with which we'll be familiar and what that we'll be using. Okay, there's additional identities beyond these, but these are the basic ones that we really want to make sure that we have down. And we're not going to worry about the other ones. There's things with there's double angle identities, and there's sine of a sum of angle identities and stuff like that, and we don't need to do that. But if you have friends in Mr. Thompson's class, they might be learning those kind of things. So, but we're not going to use them because they don't really show up in calculus at all. So again, this being pre-calculus, we're not going to worry about that. Okay. All right. So, in the interest of time, I'm not going to go through the derivation of these today. I might do it on Monday. Okay, but for right now, I'm just going to show them to you. And these are called the Pythagorean identities. And they're called that because we can derive them through a combination of using the Pythagorean theorem and our sine and cosine and tangent trig ratios. So you kind of like bring together the two big ideas, two big relationships in a right triangle, Pythagorean theorem, and you bring in the sine, cosine, and tangent, and you can put these together so that you create some new identities. And those identities are as follows. Sine squared of x plus cosine squared of x. So you can see like the influence of the Pythagorean here is equal to 1. Always. Okay, always. So if you take sine squared of an angle, you add cosine squared of that same exact angle, it will always give you an answer of 1. Okay? And then there are additional ones that are really just like manipulations of this, okay? So how can we manipulate this? Well, imagine taking sine squared plus cosine squared equals 1, and let's divide everything by sine squared. So the other way would be like sine squared. I'm just going to write it out here so you can see it, but I don't want to like disturb my nice little list I've got here, so I'll just do this. So we'll divide both sides here by sine squared, if you'll buy that this is true. We'll do what we can do okay, here. Now, technically, sine squared of x could be 0 here. So I guess we are kind of like assuming that sine won't be 0 here. So we're assuming that like x equals, well, actually, never mind. We'll still have the same domain restriction anyway, so never mind. Okay, what's sine squared divided by sine squared? 1. Cosine squared divided by sine squared is the same as saying what? Not tangent. Cotangent. Yeah, sorry, I thought I heard people say cotangent. It's cotangent squared equals, and that's what's 1 over sine squared. It's the same as what? Cosecant squared of x. Okay, so that's another one here. 1 plus cotangent squared x equals cosecant squared of x. Okay. And again, do you have to memorize all of these? No. If you just remember the first one, sine squared plus cosine squared equals 1, you can derive the others by just dividing through by sine squared or dividing through by cosine squared. So the other one we can do here is if we take our original one and then divide everything by cosine squared. Okay, sine divided by cosine will give us tangent squared x. Cosine divided by cosine will give us 1. And then 1 over cosine squared will give us secant squared x. Okay, and so there are our 3, 1, 2, 3 Pythagorean identities. All right, but it's really going to be a combination of all 6, 8, 11 of these that we're going to be using, okay, to manipulate and simplify trig expressions and trig equations as well. Okay. Bless you. Oh, yeah. No worries. Okay. So, let me show you here how we're going to be utilizing this, right? Let me show you how we're going to use this here. I guess let me try it this way. So, okay. So, an example, we might be asked to just simplify. Okay, simplify. And again, simplify is that kind of nebulous set of directions where it's like, well, how simple do we go? How do we know when to stop, right? We just kind of just keep canceling things out. And that's basically the idea here. We just want to keep canceling things out until things just won't cancel or combine anymore, okay? Right, so we're looking to combine like terms. We're looking to like cancel things from the numerators and denominators if there's fractions and stuff like that. And so that's what we're looking to do here. Okay, so let me start with a very basic one here. All right, number 1. We'll just do cotangent x times sine of x. Okay. Cotangent x over times the sine of x. Okay. As we see it right now, all right, we have cotangent and sine. should we use something like one of our Pythagorean identities here? Would that be applicable? No. Why not? What clues us in that that won't work here? Yeah, neither of these are squared, right? And there's multiplication. Good, okay? So like that's not really what we're going to use here to help simplify. You know, to use Pythagorean identities, we're looking for like to see a sine squared plus a cosine squared, or maybe you'll see like a 1 minus sine squared, which would then be just cosine squared, stuff like that. But here we got multiplication. There's no squareds at all, so that kind of clues us in. We're not going to use Pythagorean identity here. So we got to use one of the earlier identities. Okay, so what might be a helpful way to rewrite this here? So, yeah, Ethan?
You could make cotangent of x equals cosine x over sine x.
Right, let's rewrite cotangent in terms of sine and cosine. Okay, and that's going to be a general principle to guide us here. So, you know, here's like a tip. All right. Rewrite in terms of sine / cosine. It's not always necessary to do this, but if you find yourself stuck, that's a good strategy to use, because every trig function can be rewritten in terms of sine and cosine. And why is it important to rewrite it all in terms of the same thing is because you need like terms to cancel, right? So rewrite everything in terms of one thing here. All right, so now that we have this, does anything simplify from here? And the signs do, right? This is really sine of x over 1, and so I'm going to have a sine in my numerator and a sine in my denominator, so those functions can exactly cancel, and I'm left with just the cosine of x here. Okay, and technically here I should say, well, these things are only equal as long as sine of x is never equal to 0. So you wouldn't want, you'd want to restrict things like 0 and pi. Okay, I'm not going to so much worry about the restrictions for you guys. I'm just more concerned that you can simplify things down. But do understand you would have to restrict the domains here, because technically cosine is fine at 0 and pi, but cotangent times sine x is not fine at 0 and pi, right? This will be undefined. This will not. But anyway, so there's our simplification, right? All right, let's try another one here. Let's do cosine squared x times secant squared x minus 1. Cosine squared x times secant squared x minus 1. Okay. So, well, again, now we see some squares show up. Right, now we see some squares show up. So I'm thinking that maybe we do want to use a Pythagorean identity here. But neither of these exactly match one of our Pythagorean identities. Right? We don't have a just cosine squared. We have sine squared plus cosine squared is equal to 1. Right? We also don't have a secant squared minus 1. We have secant squared is tangent squared plus 1. Okay? So, and again, there's a couple ways to think about this here, but so I don't know. It's your choice what we can do. There's kind of some choice here what we can do. I can see at least 2 different paths we could take here.
It's just 1 over cosine.
Okay, so Rose says secant squared is just 1 over cosine squared. This is one path to take. Okay, like this. That's one path to take. That's not wrong. Okay, question.
We could simplify it to tan squared x.
Aha. Okay, we'll follow that path next. Okay, so hold that thought. But no, that's great. That's great that you saw that too. That's important. I wanted to show both ways here, that I could see at least. Okay, how should we proceed now then, using where Rose started us off? What should we do now? What would be a good thing to kind of do to help kind of simplify some more? Distribute. Yeah, we have cosine squared in front of parentheses here, so just distribute to both terms here. Okay, as we do that, cosine squared times 1 over cosine squared is going to be just what? 1, right? And then cosine squared times 1 will be minus cosine squared. Okay. Can we simplify that any further? There's no more like terms combined, but we have 2 terms. We can take these 2 terms and actually put it down to 1 term. go back up here to this Pythagorean identity. Well, actually, let me just pause right here. Are we okay so far up to this point? Any questions up to this point? Are we okay up to this point? Okay, so 1 minus cosine squared, which one of our Pythagorean identities here can we manipulate to look like 1 minus cosine squared? The first one, the second one, or the third one? The first one, right? If we subtract cosine squared from both sides, what does 1 minus cosine squared equal? Just sine squared. So this ends up being just sine squared of x. And that is where I would say we should stop, right? We took 2 terms, we went down to 1 term. Now there's really nothing more for us to do. So we can say, okay, that's probably as simple as it's going to go. Okay?
When is this
Tuesday. So today and Monday we'll be working on in prep for that quiz. It's a partner's quiz, so that's the idea. You can like kind of work on stuff, you know, together and all that. So, okay. What's that, Laura? Yeah, right. No, yeah. So I will not be giving you the identities. So you'll need to remember them.
All right.
Yes. But again, these should be already securely held in your brain, as well as these two. The only new ones really are these 3. And again, the only one you need to know is this one, and then you can derive the other 2 by just dividing through by sine squared or dividing through by cosine squared. Okay, so. No, we will then have a, for verifying trig, I don't think it shows up on the next test. I think it's just for the little quiz, and then the test will have, there will be another test still, but I don't think verifying trig shows up on that. I'll have to check on that though. Quiz Tuesday. Test will not be next week. Test will be in the new year. Yeah, I know. I'm sorry to disappoint you that I can't deliver a test the week before.
Technically, we don't have a test till next year.
That's right. Test is next year. All right, so let's talk about what Laura said, though. So if you guys, Laura was able to see, secant squared x minus 1. If we subtract 1 from both sides here, then I will get secant squared x minus 1. And what does it replace? It's going to be a tangent, or what replaces it? It'll be a tangent squared. So I could rewrite this as cosine squared x times tangent squared x. So yes, I'm doing the same problem again, okay, but just to show you that there's different ways to go, which can make this somewhat, that can add to the challenge or the complexity here, is that you can follow kind of different paths, okay? And different people will go different ways. So the partner's quiz, sometimes you and your partner might be going different ways with the same problem.
What happened?
So secant squared x minus 1 is a manipulation of this Pythagorean identity here. If I subtract 1 from both sides, I get secant squared x minus 1, and I'll be left with tangent squared x over here. So that is tangent squared x. Okay? Now, how can we further simplify from here? Tangent squared will be, let me get this right here, cosine squared x. Tangent squared will be sine squared x over cosine squared x. And then what happens here? The cosine squareds cancel, and we're left with that sine squared. Okay, so we see same thing. Okay, is one way better than the other? Maybe, not really though. I mean, as long as you get to the final answer there, that's what we're looking for. Okay.
Whichever one sticks in your brain the easiest.
Yep, whichever one you kind of see. Okay, but you'll notice the first path we followed went along with that tip of rewriting in terms of sine and cosine, right? So you see rewriting in terms of sine and cosine works, okay? It does work, but then also you don't have to do that first, right? In this case, we didn't have to do it at first, but then we eventually did need to do it to be able to cancel and simplify. So, all right, questions on any of that so far? All righty. Let's do one more here, and then I'll show you something else. Well, not something else. We'll show you the verifications. Okay? Let's simplify cosecant over cotangent. Cosecant of x over cotangent of x. Okay? So, should we use the Pythagorean identity here? Probably not, right? Because there's no squares. All right, so instead, let's fall back on our old strategy of rewriting things in terms of sine and cosine. So cosecant is the same as what? 1 over the sine. And then cotangent is the same as cosine x over sine x. Ah, now you can see why Mr. Widmeyer gave us those warm-up questions. We have a fraction divided by a fraction, right? So this is what I was trying to prepare you for here. Right, so instead of dividing by the fraction, we will multiply by the reciprocal. So instead of dividing by cosine over sine, we'll multiply by sine over cosine, like so. So, of course, yes, the sine x's will eliminate. One from the numerator, one from the denominator. We're left with 1 over the cosine of x, which is really what? Secant x. Okay? So in some sense, we're kind of creating our own identities. But of course, I don't expect you to remember like all these little idiosyncratic oh, if you ever see cosecant over cotangent, that's secant. I don't expect you to remember that. But in a way, we are kind of creating identities here, right? We're saying these things are equal. All right. Questions on any of that? So let me pause really quick here and just check. Or actually, let me have you guys try one. Let's do that. All right, y'all try. Let's see here. Let's do secant of x times sine of x over tangent of x. Okay, so try that one. Secant of x times sine x over the tangent of x. Okay. Try that one. See if you can figure it out. These are kind of like little puzzles, I would say. Maybe. Maybe not. This is also going to be one of your homework problems too, so double bonus. Well, I guess I'm going to need that. It's not a trick question.
Is it?
Nope.
Lies.
Okay.
You might feel like it's tricky or a trick.
I got it. I feel like that's not right. Chrissy, are you okay?
Can you get one?
Can you get one? I don't know. What do your compatriots say?
Yeah, I think so.
You don't think so?
I mean, I got one.
You got one? You got one too? Okay.
Yeah, no, I was like doing it. I was like, I'm probably not doing this right, but it's really fun.
So it just makes sense. Just look at this. It's just like
Oh my god, do you see this?
this.
Yeah. Look at my legs. I have my legs across the entire house. No, then the back.
Oh yeah, that happens to me all
Yeah,
the
so on
time.
the back of this leg.
Wait, did you go? So you can do this.
Yeah.
Well, this is like the only thing that I can do because I.
See, I think I understand something that is a test and I do really bad.
No, you do normally do fine on tests. I think what probably did you in was having that, the swimming thing the night before, right?
Just a bunch of simple.
That probably did.
No. No, we did not. But I made the response. I didn't go to Chick-fil-A with my team. I went home.
That's tough too.
I went
Missing
home. I got
Chick-fil-A.
home at 10:30.
They got their peppermint milkshakes there, I'm sure, right
But
now.
the rest of my team got back at school at 11:30.
Yeah.
It would have been worse if I went with
Right.
Chick-fil-A, but I didn't because I went to sleep.
Good for you. All right, ready? The answer is 1. It's just little old 1. Okay, so those simplify completely. All right. Your homework then is going to be questions just like these. Okay. I'm not going to get to verifying today. So on Monday, the extra twist, or I don't even know if I want to say a twist. Just on Monday, what we'll be looking at is I'll show you'll have something to simplify, and then you'll be shown what you're supposed to get to, which is maybe sometimes easier, sometimes harder. Okay. It's pretty much simplifying. It's kind of like proving, but not really. I mean, but yes, kind of. So but we'll have a goal on Monday. So in other words, like on Monday, I'll give you this. I'll give you like this problem, secant x times sine over tangent, and I'll say, show that this is equal to 1. You'll do the exact same stuff you did before. Okay? So I'll be asking something like, show that this equal to 1. And that's what the quiz will be. Okay? So the quiz will be, show that this equals 1. Or show that this equals secant x. And so on and so forth. Okay? That's what you'll be asked on the quiz. I'll give you your starting, and I'll give you where you're supposed to end, and then you gotta fill it out. Get it to match up. Get it to match up.
Like, so there's not going to be like
There won't be any that do not work out. They will all get to where they want to go.
So if we don't get it, so technically everyone should pass this.
For you, that's not
People not pass this in the past. So you basically give us the answer.
Well, so Rose said it's like a proof, right?
Huh?
Rose